Physical Quantities and Units Memo. Number 1. Match the following base quantities with their units. So mass is kilograms, length is meters, time in seconds, current amperes, and temperature is Kelvin. Number 2. Express the following physical quantities derived units as products or quotients of their SI base units. So velocity, which you could think of as length divided by time, is meters per second. Momentum, which is mass times velocity, is kilogram meters per second. Force, which is mass times acceleration, is kilogram meters seconds to the minus 2. Energy, which is force times length, is kilogram meters seconds to the minus 2 times by meters. Tidying that up, we get kilograms meters squared seconds to the minus 2. Power is energy divided by time. So kilograms meters squared seconds to the minus 2 seconds to the minus 1. We get kilograms meters squared seconds to the minus 3. Potential difference is energy over charge, which is kilograms meters squared seconds to the minus 2 divided by, well, charge is actually amp seconds, so we get kilograms meters squared seconds to the minus 3 amps to the minus 1. Number 3, match the prefix with the symbol and the decimal multiplier. Well, micro is mu and 10 to the minus 6. Tera is capital T and 10 to the 12. Pico is P and 10 to the minus 12. Milli is M and 10 to the minus 3. Nano is N and 10 to the minus 9. Deci is D and 10 to the minus 1. Kilo is K and 10 to the 3. Giga is capital G and 10 to the 9. Mega is capital M and 10 to the 6. And finally, centi is C and 10 to the minus 2. An analog ammeter's needle is bent and reads 0.6 amperes when no current flows. Will this cause a systematic or random error, and explain? Well, it's systematic because every value would be biased by the same amount. Number 5. During several experiments, a laboratory measures the Earth's gravitational field strength as 6.24, 6.13, 6.31, 6.29, and 6.32 meters per second squared. Given that the Earth's gravitational field is really 9.81 meters per second squared, the distinction between precision and accuracy of these results. Okay, well, the values are precise because they're all very close together, but they're inaccurate because the average value is nowhere near 9.81. Number 6, a meter rule is used to measure the length of a room as 6.67. Now the meter rule was marked to the nearest centimeter and has an absolute uncertainty of plus or minus 1 centimeter. What's the total absolute uncertainty for the measurement of the length of the room? Well, we're going to have to use the meter stick 6 times, so therefore it'd be 5.67 plus or minus 0.06 meters. A runner runs 100 plus or minus 2 meters in a time of 20 plus or minus 1 seconds. Find the velocity and the percentage uncertainty in the velocity of the runner. Well, velocity is displacement over time, so that gives us 100 divided by 20 is 5 meters per second. But what about the uncertainty? Well, the uncertainty in the distance is 2 divided by 100 times 100, which gives us 2%. The uncertainty in the time is 1 over 20 divided by, times by 100, and we get 5%. Because we're dividing displacement by time, we add percentage uncertainties, and we get 5 plus 2%, which gives us 7%. So the velocity is 5 meters per second plus or minus 7%. Okay, explain the fundamental difference between scalar and vector quantities. Very, very common question. Scalar quantity only has magnitude, whereas vectors have magnitude and direction. Give 3 examples of scalars. Well, I've put mass, distance, and time. 3 examples of vector quantities would be displacement, velocity, and acceleration. 9, a boat motors in a northerly facing direction with a velocity of 5 meters per second, whilst the tide moves the boat in an easterly direction with a velocity of 2 meters per second. What's the resultant velocity, including direction? Well, we're going to use Pythagoras because the two velocity vectors are 90 degrees to each other. We can just use Pythagoras. So 5 squared plus 2 squared, all square rooted, gives us a resultant velocity vector of 5.4. What's its direction? So we're going to use tan because we've got the opposite and the adjacent. So tan to the -1 of 2 over 5, we get 21.8 degrees east of north. Finally, a ball is kicked with a velocity of 12 meters per second and an angle of 30 degrees to the horizontal. Find the instantaneous vertical velocity and the horizontal velocity. Well, the vertical velocity is going to be 12 times sine 30, which is going to give us 6 meters per second. The horizontal velocity is going to be 12 times cos 30, which is 10.4 meters per second.